All right, here we go with amplitude, which we've kind of already talked about when we discussed initially the graphs of sine and cosine. So what I'm going to do is I'm just going to really quickly graph all four of these on the same set of axes. And you can kind of see what is going to be going on here. So the first one, sine x, that starts at 0, goes up to 1, down to 0, down to -1, and back up to 0. So there we go. Okay, so then when we go to the 2 sine of x, everything that changes is the 1's turn into 2's. 0 stays the same, -1 turns to -2, 0 stays the same. So what happened was the graph got stretched. Right. Alrighty, so there's 2 sine x. When we go to do half of sine x, we're still at 0, but now we're only going to go up a half, which is about right there. Still at 0, down at -1/2. So what happened was this kind of got compressed, right? So if we go to graph this, it got flattened. Okay, and then when we have, let's see if I can change the color here to purple, negative sine x. Now what that means is that we're going down to -1, back up to 0, up to +1, down to 0 again, and connecting the dots. Okay, so we can see that for each of these, what changed was the number in front of the sign of x. And so when it's just 1, we go up to 1. When it's 2, we go up to 2. When it's a half, we go up to a half. When it's -1, we go down to -1 first. All right, so these numbers in front help us figure out the amplitude. And amplitude is defined as 1/2 the maximum minus the minimum. So really it is how high or how low are you going in your curve, the height of your curve. So when you look at this, if we tried to figure out, say, the amplitude for y = 2 sine x, well, the maximum is 2 and the minimum is -2. So 1/2 of 2 minus a -2 is just 2. Okay, so when you're looking at your y = sine x or y = cosine x curve, or the equations, the a, so now we're going to start putting these letters in here for the parameters, the capital A is going to represent our amplitude. And when you want to figure out what the amplitude actually is, you take the absolute value of it. So for example, with this purple curve, where y = a negative sine x, the -1, which is a, your amplitude is actually a +1. And if you think about it, plugging it into this formula, your maximum is a +1, your minimum is a -1. It doesn't matter which came first, you just plug those in. So 1 minus a -1 is 2, and then you divide it by 2, you get 1. Okay, so really easy trick is to just look at the number that's multiplied to the sine or cosine curve, take the absolute value of it, and that is your amplitude. Okay, so let's do one more example here. So if we have y = -5 cosine x, we're going from 0 to 2 pi. You would set this up. These are the values that you see on the x and y axes that I would be looking for if I were to be grading this on a test. Okay, so we have to have our maximum and our minimum. You do need to put these little markings so I know that it is evenly spaced, right? And your 4 quadrantal angles, including your 0. So actually 5, right? Because we repeat the 0 and the 2 pi. Okay, so if we were to graph this, -5. So cosine normally starts here at +1. So instead, we're going to start down here at -5, because +1 times a -5 gives you -5, right? Okay, and then following the pattern, we would go up to 0. And then at the next quadrantal angle, we're going to be up at +5. back down to 0, and then back down to -5. Okay, so hopefully you guys are getting a little bit more comfortable with these sine and cosine curves and what they typically look like. So when I connect the dots, here we go. Ooh, that was beautiful. Okay. I guess slow and steady really is the right way to go, huh? Okay, so when you look at this, there's your graph, and if you needed to read off what your amplitude is, the amplitude is a +5. All right, that's it. Hopefully that wasn't so difficult for you.